Question 17 asks us, how do we make a box plot? So in StatCrunch, we can make a box plot, but how is it created? The box plot is made up of your 5-number summary. So you first put dots on your graph for the 5-number summary, and then we connect them. We have what's called a skeletal box plot and a modified box plot. StatCrunch will always make a modified box plot, but if we're doing our calculations by hand, we would typically do a skeletal box plot. You will always use StatCrunch, but I just want you to know that the ones that we're going to do right now are not going to take into account any outliers. Let's first make points for the sodium data set for the 5-number summary that's listed here. We have dots at 0, 130, 180, 210, and 320. And there's a grid here just so you can see what that looks like. Typically in our box plot, you won't see a grid like that. As you've seen in StatCrunch, it's just a picture above a number line. The box, remember, is the quartiles from Q1 to Q3. So we draw a box from 130 to 210. There's a line down the middle for the median, and then the whiskers, because it used to be called a box and whisker plot in some books. The whiskers come from attaching the quartiles to the maximum and the minimum. If I was to make a box plot, it would look like this. This is the interquartile range that is noted by the box. Q3 all the way up to the maximum, Q1 down to the minimum. But again, when we were in StatCrunch, they stopped the picture and then represented an outlier. If we're doing it by hand, we're just going to do, this is what's called a skeletal box plot, but StatCrunch is always going to make a modified box plot. You don't really need to know the difference between the two. You will always be using StatCrunch for calculations. Now we're going to make a box plot for potassium. So we're going to do the same steps that we did earlier for the sodium graph. And we're going to ask if there's any outliers, how many, how do we know, and what shape does this distribution have? So let's switch over to StatCrunch now. And we're going to graph a box plot of potassium now. Again, I'm going to draw mine horizontally just because that's the way that I prefer it. I prefer to see a number line from left to right. And question 18, part A says, does this data set have any outliers? Yes, I can see in this picture that there are 4 dots. So I have at least some outliers in the upper area. I see 4 dots. So there are at least 4. But the way that we know for sure is we hover over the image and it tells us, second line, number of outliers is 4. And the way that we tell using only the visual of the graph is by looking at how many dots there are. The dots represent outliers. What shape does this distribution have? Well, think about a shape. We've got skewed, symmetric, or uniform. We don't know if this is bimodal or unimodal or anything based on the box plot. We really can't tell that because I don't know what my peaks are. All I know is that there's a lot of data to the left and there's not a lot of data to the right. So a lot of data to the left and not a lot of data to the right means that this is skewed to the right. This is pulled towards the right-hand side. So the tail, the skewness is pulled to the right. So this graph is skewed right. Now we're going to create some comparative box plots, or we're going to stack 2 together on the same number line. Question 19 asks us to make box plots for sugars and carbohydrates. Same way that we did potassium and sugars, we just select both of them at the same time. So we are going to graph a box plot, and I'm going to hold down my shift key to get carbohydrates and sugars. They happen to be next to each other, so I can use the shift key. You could also use control if they weren't grouped together. And I'm going to draw my box horizontally, and then I'm going to click compute. Question A says, how does the spread of the data sets compare? Spread, variability, how variable are these? I can't tell anything about standard deviation, which we haven't covered yet from this. The only thing I can see is my range and my interquartile range. And we know that interquartile range is a better measure of spread than range. So how do their IQRs compare? Let's say that the interquartile range of sugars is something in comparison to the interquartile range of carbohydrates. Looking at my interquartile range, the box for sugars is larger than the box for carbohydrates. This means that the interquartile range for sugars is larger than the interquartile range for carbohydrates. It is more spread out. So sugars is more spread out than carbohydrates. There's more variability. Let's hover over our image to get the IQR for each. The IQR for sugars was 8, and the IQR for carbohydrates was 5. So yes, 8 is larger than 5. How will typical data values for each set compare? Typical values, middle values. How does the middle of sugars compare to the middle of carbohydrates? The middle for sugars is less than the middle for carbohydrates. The median line, that middle line that goes through the box, the middle line here is less than the middle line for carbohydrates. So sugars has a smaller typical value than carbohydrates. Let's figure out what those values are. If you hover over sugars, we see that the median is 7, and carbohydrates has a median of 14.5. So sugars has 7 grams for a typical value, where carbohydrates has 14.5 grams. So more carbs than there are sugars typically in these cereals. I'm going to go back to sharing my notes so that you can see what I wrote. Back here for 18, yes, there were at least 4, and the dots represent outliers. The distribution was skewed to the right. That was for potassium. And then when we were comparing sugars and carbohydrates, the IQR for sugars was larger than the IQR for carbohydrates, so it was more spread out. There was more variability for sugars. But sugars had a smaller typical value than carbohydrates, 7 grams compared to 14.5 grams. That's it for Module 9. You're going to investigate standard deviation in Module 10. Thanks for watching.